Hey guys, today we're going to be talking about a little bit more stuff that's going to make you successful on functions. So first we're going to look at what a graph looks like on a function. There's lots of different pieces on a graph that are important. It's typically made up of two axes, which are the x-axis and the y-axis, which divides it up into four different quadrants, we call it. Quad, four. Quadrant 1 starts up in the top right, and that has a positive x value and a positive y value. Then we move counterclockwise around from that way. Quadrant 2, our x value is negative, our y value is positive. Quadrant 3, both values are negative. And then quadrant 4, we have our x value positive and our y value is negative. The way you look at this is our x's, everything to the right is positive, to the left is negative, and our y's, everything to the top is positive and the bottom is negative. This is basically two number lines put together to make a graph. Okay, there's lots of other words that we use when we're talking about the x-axis in functions, and some of them could be input. Another one also is our x's we talked about already, is in our domain, and then x is also our independent variable. Okay. Then y is our output or our range, and then it's our dependent variable. Everything depends on what happens with y for us to get our x values. Okay, another pretty simple concept is finding the inverse of a function. It's usually represented by saying whatever the function is raised to a -1 power, we're taking the inverse of it. So I have a function listed right here, 4, 3, 2, -6, 5, 4, and 0, -2. Okay, it's asking me to take the inverse of this function. So a raised to the -1 power is saying, okay, let's take the inverse of a. And it's pretty simple. All you have to do is switch the x and y values. So for the original a, we have all of our x and y values here. And for our inverse, we have our y values listed first and our x values listed second. Okay, so I flipped here. We have 3, 4. Same thing here. -6, 2. Again here, 4, 5. And then -2, 0 for our inverse. Okay, we'll talk a little bit more about function notation and what you can see out of function notation. A little bit more in depth of what the f means on f of x. F is the name of the function. So we could have A, we could have G, we could have H. They use all different letters to name the function. X is the domain, okay, so it's our input, it's the independent variable, and f of x is the range. That's what's going to come out of it after we've put in our domain, okay? So here's an example of a function written in function notation, 3x minus 5, and I'm given domains, 0, 1, and -1. I'm asked to find the range right here. So what you need to do is you need to go in separately and plug in these ranges and find the individual plug in these domains and find the individual ranges, and then that's going to give us our ultimate answer. So here I have f of 0, and we have that f of 0 equals -5 from the math here. F of 1, 3 times 1 minus 5 is -2. And then f of -1, 3 times -1 minus 5 is -8. So the range values in corresponding to these three domain values is -5, -2, -8. Okay, I have an example here at the top for you to do on your own. You can pause the video and I will walk through it with you after you've already done this on your own. It's f of x equals 2x squared plus 3x minus 1. The domain values are 0 and 2, and I'd like you to find the range. Okay, so if I plug in 0 for my x value, I must plug in 0 everywhere there is an x. So 2 times 0 squared plus 3 times 0 minus 1 is going to equal f of 0. So 0 squared is 0, 2 times 0 is 0, 0 plus 0 minus 1. So f of 0 is -1. Okay, so that's our first range value. Our second range value I need to plug in 2. That's our first. So f of 2, so 2 times 2 squared plus 3 times 2 minus 1. F of 2 is the same thing as saying 4 times 2, 8, plus 6 minus 1. Okay, f of 2, 8 plus 6 is 14, minus 1, so f of 2 equals 13. So then therefore, our range values for this domain of 0, 2 is going to equal -1 and 13.